Orange County awoke to the kind of emergency that usually exists only in disaster planning documents. More than 50,000 residents across several Southern California communities were ordered to leave their homes after authorities warned that a massive industrial chemical tank was becoming dangerously unstable. Schools closed, roads filled with departing families. Emergency shelters opened as fire crews and hazardous materials teams raced against rising temperatures inside a storage vessel containing thousands of gallons of toxic material. In a region better known for beaches, tourism, and sprawling suburbs, an aerospace facility suddenly became the center of one of California's largest chemical evacuation crises in years. Residents in parts of Garden Grove, Anaheim, Stanton, Cypress, Buena Park, and Westminster were told the danger was immediate enough to justify mandatory evacuations. Officials warned that the tank could rupture, ignite, or release toxic vapor into densely populated neighborhoods. The threat spread across an area packed with homes, apartment complexes, schools, businesses, and major highways. The evacuation zone covered miles of heavily urbanized Orange County territory, creating an emergency that extended far beyond the industrial property where the crisis began. At the center of the incident stood a large storage tank at a facility operated by GKN Aerospace. Authorities said the tank contained between 6,000 and 7,000 gallons of methyl methacrylate, a highly flammable industrial chemical widely used in plastics, resins, paints, and aerospace manufacturing. In metric measurements, that volume equals roughly 22,700 to 26,500 liters. Emergency crews feared the tank had entered a dangerous thermal reaction that could increase internal pressure until structural failure occurred. The scale of concern grew rapidly after firefighters realized that conditions inside the tank were not stabilizing. Initial operations focused on cooling the container with water streams and monitoring vapor emissions. But by Friday night, emergency officials announced that temperatures inside the vessel had continued rising despite those efforts. Reports indicated the internal temperature had climbed from approximately 77 degrees Fahrenheit, or about 25 degrees Celsius, to roughly 90 degrees Fahrenheit, close to 32 degrees Celsius, with temperatures increasing at nearly 1 degree Fahrenheit every hour. That temperature trend transformed what began as a hazardous materials response into a regional emergency. Authorities worried that the combination of heat, chemical volatility, and pressure buildup could trigger a catastrophic failure. If the tank ruptured violently, it could release toxic vapor across residential areas. If ignition occurred, the resulting explosion might send debris and flames outward into surrounding industrial and residential districts. California Governor Gavin Newsom declared a state of emergency as the crisis intensified. The declaration allowed state resources to move rapidly into Orange County, including specialized hazardous materials teams, emergency shelter coordination, environmental monitoring support, and logistical assistance. The emergency declaration also reflected the extraordinary population density surrounding the industrial site. Orange County is one of the most heavily populated urban regions in the United States, and the threatened area included thousands of homes within a relatively compact geographic footprint. A toxic release in such a setting carries different consequences compared with similar industrial accidents in remote locations. Roads become congested almost immediately. Evacuation routes narrow quickly. Shelters must accommodate large populations within hours. Hospitals prepare for respiratory exposure cases even before a release occurs. Officials repeatedly emphasize that the danger involved not merely a leak, but the possibility of multiple outcomes unfolding simultaneously. Fire authorities described concerns about vapor release, explosion risk, airborne contamination, and environmental runoff. Crews reportedly constructed protective barriers near storm drains and waterways to prevent any discharged chemicals from spreading into local water systems. Methyl methacrylate itself became a major point of public concern once the name of the chemical entered national headlines. The compound is a volatile liquid commonly used in manufacturing environments. Exposure can irritate the eyes, skin, nose, and respiratory system. High concentrations may produce dizziness, headaches, nausea, and breathing difficulties. Authorities warned residents to avoid contact with fumes and instructed those outside evacuation zones to shelter indoors if conditions changed. The situation became more alarming because responders reportedly encountered problems with the tank's relief systems. According to emergency updates, valves intended to reduce pressure were not functioning as expected. That forced crews into a difficult position. Direct intervention near the tank carried obvious danger, yet allowing temperatures to continue rising unchecked presented another potentially catastrophic scenario. As the Memorial Day weekend unfolded, thousands of evacuees faced uncertainty about when they would be allowed home. Emergency shelters opened in neighboring communities while local authorities coordinated transportation assistance and temporary accommodations. Some residents reportedly refused evacuation orders, a recurring problem during large-scale emergencies in California. Officials continued urging compliance, warning that conditions around the tank remained unstable and unpredictable. The geography of the crisis added further complications. The industrial facility sits amid a patchwork of warehouses, businesses, residential neighborhoods, and transportation corridors characteristic of Southern California urban development. Unlike isolated refinery zones built far from population centers, this site existed within the daily movement patterns of tens of thousands of people. Within a short driving distance stood schools, shopping areas, apartment complexes, and tourist destinations. Even Disneyland, located less than a mile from portions of the affected region, monitored developments closely while remaining operational outside the evacuation boundaries. Authorities also explored increasingly unconventional stabilization methods, as traditional cooling operations failed to reverse the temperature increase. Reports indicated hazardous materials, specialists and industrial chemical experts from across California were brought into the response effort. Emergency crews reportedly attempted to neutralize nearby tanks to reduce the possibility of a chain reaction if the primary vessel failed. The danger of chain reactions in chemical storage incidents has shaped emergency planning for decades. Industrial chemicals stored in bulk quantities can become exponentially more dangerous once heat transfers between neighboring containers. A failure in one tank can damage adjacent structures, releasing additional flammable or toxic substances into the environment. That possibility appeared to influence firefighting tactics around the Garden Grove facility, where crews sought not only to stabilize the primary vessel, but also to isolate nearby hazards. Drone monitoring became another important component of the response. Authorities used aerial surveillance to observe the condition of the tank without placing personnel directly within the highest risk zone. Thermal imaging and remote sensing technologies allowed crews to track temperature changes and detect signs of structural deformation from a safer distance. At the same time, local air quality monitoring systems operated continuously around the evacuation zone. Officials repeatedly stated that no major toxic plume had yet been detected beyond the immediate area, but the absence of a release did not reduce concern. The entire evacuation strategy rested on preventing casualties before a catastrophic event occurred, rather than reacting afterward. California's long history with industrial accidents, wildfires, earthquakes, and environmental disasters has shaped an aggressive emergency management culture that often favors large precautionary evacuations. Officials appeared determined to avoid the type of delayed response that historically turned industrial incidents into mass casualty events elsewhere. The Garden Grove crisis also exposed broader questions about industrial storage safety in rapidly urbanizing regions. Southern California contains thousands of industrial facilities operating near residential populations. Over decades, urban sprawl gradually surrounded manufacturing zones that once stood farther from dense neighborhoods. Warehouses became bordered by subdivisions. Factories found themselves near apartment towers. Logistics centers expanded beside schools and retail corridors. That overlap between industrial infrastructure and civilian life creates persistent tension in metropolitan planning. Facilities handling hazardous materials often remain legally compliant while still posing risks when accidents occur. Even a relatively localized failure can trigger evacuations, affecting tens of thousands of people, simply because modern urban density leaves little physical separation between industrial and residential land use. The emergency response also highlighted the logistical complexity of evacuating 50,000 people from Southern California suburbs. traffic congestion in Orange County is already among the most severe in the United States during ordinary conditions. A sudden mass evacuation introduces additional complications involving fuel availability, shelter capacity, communication systems, and medical access. Authorities issued evacuation maps, emergency alerts, and shelter instructions across multiple platforms, while law enforcement officers established road closures near the facility. Public messaging emphasized both urgency and order, attempting to prevent panic while encouraging rapid compliance. Meanwhile, crews working nearest the tank faced exceptionally dangerous operating conditions. Hazardous materials incidents involving unstable chemicals differ significantly from conventional fires. Water application can sometimes worsen chemical reactions. Certain compounds react violently to oxygen exposure, friction, or temperature changes. Firefighters and hazardous materials technicians must constantly balance intervention against the possibility that intervention itself may trigger disaster. Historical industrial accidents in California demonstrate how quickly chemical emergencies can escalate. The state has experienced refinery explosions, pipeline ruptures, toxic spills, and industrial fires over past decades. One notable incident near Santa Paula in Ventura County during 2014 involved a volatile chemical reaction that injured workers and firefighters while forcing evacuations after explosive materials spread across a treatment facility. Such incidents have reinforced the importance of specialized hazardous materials units trained specifically for chemical containment rather than conventional firefighting alone. The Orange County response drew personnel and expertise from multiple jurisdictions as officials sought solutions before the tank reached critical failure conditions. Legal and regulatory questions also emerged almost immediately after evacuation orders expanded. Orange County District Attorney officials reportedly began examining the circumstances surrounding the tank failure, including whether maintenance issues, inspection lapses, or operational problems contributed to the emergency. Industrial storage tanks handling volatile compounds typically operate under extensive safety regulations, involving pressure monitoring, ventilation systems, temperature controls, and emergency shutdown procedures. When failures occur, investigators often examine maintenance histories, inspection records, sensor performance, employee training practices, and compliance documentation. The Garden Grove incident unfolded at a moment when public scrutiny of industrial risk management has grown increasingly intense nationwide. Communities living near chemical plants, refineries, rail corridors, and manufacturing facilities frequently demand greater transparency about hazardous materials stored nearby. Large-scale evacuations amplify those concerns because they transform abstract industrial risk into visible public disruption. For residents forced from their homes, the crisis became deeply practical rather than theoretical. Families gathered medications, pets, clothing, and important documents before leaving neighborhoods under mandatory orders. Businesses shut down operations inside evacuation zones. Hotels filled with displaced residents. Community centers transformed into temporary shelters. Emergency management agencies also confronted the challenge of maintaining public trust amid uncertain conditions. Hazardous materials incidents often evolve rapidly, with officials updating risk assessments as new information emerges. Initial estimates may change. Evacuation zones may expand or contract. Stabilization strategies may fail and require replacement. Authorities in Orange County issued repeated updates as crews monitored tank temperatures and structural conditions around the clock. The incident drew national attention partly because the threatened outcome remained hypothetical, yet potentially devastating. No major explosion had occurred. No massive toxic cloud had swept across neighborhoods. Yet tens of thousands remained displaced because officials believed those outcomes were plausible enough to justify extraordinary precautions. That tension between visible calm and underlying danger created a uniquely unsettling atmosphere across Orange County communities. Residents could see clear skies while knowing that emergency crews nearby feared a possible industrial catastrophe. Roads outside evacuation areas remained busy. Tourist destinations stayed open. Yet only a short distance away, firefighters operated under the assumption that a single structural failure could transform the situation instantly. environmental concerns extended beyond immediate human exposure. Authorities prepared containment systems to prevent chemicals from entering storm drains, groundwater channels, and coastal ecosystems if the tank ruptured. Southern California waterways already face intense environmental pressures from urban runoff, industrial pollution, and coastal contamination. A large-scale methyl methacrylate spill could introduce additional ecological damage requiring long-term cleanup operations. The crisis also underscored the importance of communication infrastructure during emergencies. Evacuation orders reached residents through mobile alerts, television broadcasts, radio updates, social media platforms, and law enforcement notifications. In densely populated regions, rapid information dissemination can determine whether evacuation traffic remains manageable or devolves into gridlock. By the weekend, emergency officials continued searching for ways to cool and stabilize the tank while avoiding direct actions that might trigger failure. The operation evolved hour by hour as crews assessed temperature data, monitored structural integrity, and adjusted response strategies. Authorities repeatedly stressed that the evacuation orders were not precautionary in the casual sense of the word. They reflected genuine concern that conditions could deteriorate quickly if the tank breached or ignited. Even a relatively limited release could spread toxic vapor across nearby neighborhoods depending on wind direction and atmospheric conditions. Nightfall brought little relief to emergency operations because hazardous materials incidents rarely pause once daylight disappears. Fire crews maintained continuous monitoring around the aerospace facility while mobile command units coordinated with county, state, and environmental agencies. Thermal readings from the tank remained the central concern. Every additional degree raised questions about how much time remained before the container might fail under increasing internal pressure. Authorities established layered safety perimeters extending outward from the industrial site, with the innermost zones restricted almost entirely to specialized response personnel wearing protective equipment designed for toxic exposure environments. The evacuation itself exposed how interconnected Orange County's communities have become. Many residents forced to leave crossed only a few miles before reaching safer zones, yet those short distances dramatically altered the level of risk according to emergency planners. Hotels in neighboring districts reported surging demand as displaced families searched for temporary accommodations during the holiday weekend. Restaurants and businesses outside evacuation boundaries experienced unusual spikes in activity from evacuees waiting for updates while trying to maintain some sense of normal routine. Public transportation agencies also adjusted operations as road closures spread around the affected region. Traffic diversions redirected vehicles away from industrial corridors near the facility, creating congestion along alternate routes already crowded by regular Southern California weekend travel. Emergency planners faced the complicated task of balancing rapid evacuation movement with the need to keep major access roads available for fire engines, hazardous materials units, ambulances, and law enforcement convoys moving toward the scene. Inside the evacuation perimeter, silence replaced the usual suburban activity. Residential streets that normally carried steady movement of vehicles, delivery trucks, cyclists, and pedestrians became largely empty except for patrol units and emergency vehicles. Businesses closed storefronts. Schools suspended activities. Parks and shopping centers stood vacant as officials attempted to minimize civilian exposure in case conditions deteriorated with little warning. The industrial character of the surrounding district added another layer of complexity to the emergency. Warehouses and manufacturing buildings near the unstable tank contained additional chemicals, fuels, and combustible materials that responders needed to account for while planning containment operations. Emergency maps reportedly identified nearby facilities with potentially hazardous inventories, so crews could prioritize protection strategies if the primary tank failed. Industrial incidents often become exponentially more dangerous once secondary fires or chemical releases begin spreading through neighboring structures. Authorities also had to consider weather conditions hour by hour. Wind direction represented one of the most critical variables in determining how toxic vapors might travel if a release occurred. Even moderate shifts in airflow could alter which neighborhoods faced the highest exposure risk. Atmospheric stability, humidity, and temperature inversions all influence how airborne chemicals disperse across urban environments. Emergency planners continuously updated projection models while preparing contingency plans for multiple possible release scenarios. As crews continued their operations, the incident increasingly became a test of whether preventative emergency management could succeed before disaster struck rather than afterward. Authorities hoped the evacuation would ultimately be remembered as an aggressive precaution instead of a response that arrived too late. The difference between those outcomes depended entirely on whether firefighters and hazardous materials specialists could bring the unstable tank under control before temperature and pressure reached irreversible levels.